Hey, so we're gonna continue with 6.3 and 6.4 today in class. Uh, both sections 6.3 and 6.4 and 6.5. Sorry, 6.4 and 6.5. Both sections are graphing. So I will teach you how to graph sine and cosine, which is 6.4 and 6.5. 6.4, and then 6.5 we'll talk about how to graph a tangent, cotangent, secant, and cosecant graph. So there are 6 graphs that you need to know. So this is something that is quite important. Okay. So let me share the screen here for you guys. So the first thing I want to point out here is that we will talk about this method test. So this coming Friday, November 5, we have a student method test in the fall, and there will be one in spring, very close to spring break, around spring break. I mean, not in spring, but around spring break time, either before or after spring break. So what is this student method test? This student method test consists of 20 multiple choice questions. It will be every correct answers you will get. Every correct answers that you have when you do the student method test will be a positive 2 points. Every wrong answer is a negative half. So you got 20 multiple choice. It is 1 hour to do it, and it's a very difficult test. This test consists of questions that are very it's like what you learn here, trig and not calculus, trig and algebra, but it is a bit more difficult. It has some probability, it has some stats, you have some logic questions. You have to think about this one. Beside the cash, yes, there'll be first, second, third place cash prize here. Beside this cash, I also provide you some extra credit. So this is a student method test. This is coming on this Friday. It will be from 12 to 1 o'clock in CLA 116 this Friday, November 5th. So every correct answer is positive 2, every wrong answer is half a point. And this is something I will want you guys to come and take it. So the total points will be added to your test 3 as your extra credit. So I would recommend you guys to come and take this student method test, which is on Friday, this Friday, from 12 to 1 at CIA 116. So if you get correct answers, you get added 2 points. And don't forget, if you just simply answer all CCCC, I won't give you any points because you probably will get 0 or negative points. So if you have 0 or negative points, that means you get nothing to add it to your test 3 as extra credit. But if you get a positive total results, then that will be added to your test 3. Means if you get like plus 10, means you get 10 points extra added to your test 3. This method test is very difficult. I can only answer like 6 or 7 questions out of 20 questions in an hour. And I think mostly I should get 1 wrong, and the rest, like I should get like 12 or 13 points, something like that. So it's really, really, really difficult. I would recommend you to take it, and I will post this in D2L. I do have some old tests from last 2 years. We used to have every year, but last year due to COVID, they cancel it. So I have it 2019 and 2018, and I got the answer, the solutions, how to work that out. So if you need help, or if you want to look at it and try to do it and see what's going on, you can participate. And don't forget that you will also get another round in spring, and it's the same price, cash price. And then after that, we'll add your total points, and we'll send it to the American Math League here, so that our college will represent the American and see where do we place. Okay, usually we are not that high. Californians are usually the crazy ones, but anyway, so it's fun. So I would recommend you to come. You can use a graphing calculator for this test. So anyone have any questions with the math lead test here that is coming out on this Friday? If you do, let me know. I'm the one that actually in charge of this. And for my class, I will let you guys to have extra credit added to your test 3. So any points you add up. So please do not just come in, circle all the C's, and then leave. Okay, like take you 10 minutes to do it. You probably won't get any points from that. So I want you to try it. And when I say try it, make sure you know that answer is correct, because if it's wrong, you get a negative half points. Correct, you get positive 2. So if you leave it blank, it's 0. So I recommend, if you doesn't know it, leave it blank. Okay, don't simply put all C's or all B's or something else. What is inside these kind of questions? Very difficult, challenging ones. So you will see it. Okay, so I will give you will see some examples that I'll put in D2L. So that's a method test. Okay. Questions? So we're gonna talk about how we draw our sine and cosine graph today. So, and then hopefully I also have time to do secant and cosecant because they are very similar. So we talk about the sine and cosine graph. Shut up, don't do that anymore. So we talk about sine and cosine graph on our previous Wednesday class. So the sine graph in this case is given us by a hill and a valley, which is right over here, a hill and a valley. And these are the 5 important points. And the domain is all real numbers. The range is from -1 to 1. The y-intercept is at 0, 0. And the x-intercept is k pi 0, where k is integers. And this sine graph is an odd graph, which is symmetrical with its origin. So this is the sine wave that we have. And then we also draw the cosine wave. The cosine wave is where it goes all the way down and then up. So these are the 5 important points for cosine. And if you doesn't know how to figure out it, is you use your unit circles and you just use a 0, pi over 2, pi, 3 pi over 2, and 2 pi. And for sine, you use the y value. For cosine, you use the x values. And that's how we figure out these points. And you graph it. And the domain, the period for both sine and cosine is 2 pi. The domain is all real numbers. The range -1 to 1. The y-intercept is 0, 1. The x-intercept is pi over 2 plus k pi, 0. And this is an even, which is symmetry to the y-axis. So this is the basic the sine and cosine graph. Okay, so this is without any transformation. So I also mentioned that in order for you to graph this sine and cosine, there are 2 ways to do it. One way is using transformation, means up, moving down, moving left, moving right, reflections, and all those vertical shrinking and stretching, vertical and horizontally. You can do that. However, we can also do another way, which is I will teach it in this today's class. Which is taught by the textbook. So we're gonna do graphing of this. Okay. So if you look at your notes here, so mostly what we have in this case when you do sine and cosine is we got 4 different things. One is the A, which is always in front of the sine and the cosine. B, the one next to your x, like your slope. Okay, but it's not slope because something else. C is the one that is next to it, and make sure this is the minus C, and they are inside this parenthesis after sine or cosine, and then plus D. Okay, so these are the A, B, C, D is the 4 transformations that we will have in this sine and cosine. And again, it can be also secant and cosecant. You just need to flip it. I will show to you how the cosecant and secant graph looks like. What is this A stands for that you see up front here? That is what we call as your amplitude. Okay, so amplitude is actually the half of the distance between the maximum and the minimum. So in this case, you just take maximum plus minimum divided by 2. So that is what your amplitude is. If I give you graph, you just do the max plus mean divided by 2. Or if I give you in a formula, in a function form or equation form, then the amplitude in this case is just an absolute value of A. So this A that you see up front here, if you take the absolute value, means make it positive, that is your amplitude. So what is amplitude in this case? Amplitude is actually how the height from here to here. This is your amplitude. Okay. So in order for you to find this, you take the maximum. This is your max. And you take the minimum, which is this is your minimum. You add it up and divide by 2, and you get yourself the amplitude. Okay, same thing happens when you have a cosine graph. The amplitude is the one over here. This is your amplitude. Okay, and amplitude, the letters we use is capital A. Okay, so capital A is your amplitude in this case. Okay, period is the next one. As you know that sine and cosine is having a period of 2 pi. That is the basic period. But if you have a b exists here next to your x, then your period in this case will be stretched or shrink horizontally based on the b by performing 2 pi over b. Okay, so your period in this case is 2 pi over b. The shortcut for period in this case is capital P. Okay, so capital P is your period. So it's 2 pi over b, and b is the number next to your x in this case. If you think about transformation, this is either horizontal stretch or horizontal shrink. Okay, that means that what happens to your graph in this case is, as you know that the normal graph for sine and cosine is from 0 to 2 pi. So let's say that if your b is 2, that means your period in this case will be 2 pi over 2. So it's actually cut into half by pi. So what happens is, this is pi here. So now your sine wave is actually going to be cut by half. So it will be, instead of 0 to 2 pi, it's going to be from 0 to pi. So if your b is 2 in this case, and your b can be anything. If your b is 1/2, then your period is 2 pi over 1/2. And this is the same thing as 2 pi times 2, because you divide by half and the division will make it as multiply, and you flip your fractions. So this is actually 4 pi. So what happens when your b is 1/2? Your sine wave is going to be horizontally stretched. Instead of 0 to 2 pi, it's going to be 0 to 4 pi. So it's kind of double it. So this b that you see here is very important, and that is determine how far and how horizontal stretch and shrink we have in this case. Okay, so that is b here. Next, we're going to talk about is the next piece of transformation have is phase shift. Phase shift is where you take c divided by b here. Make sure you guys know that if you look at the formula here, your c in this case is negative inside. So if your c here is a positive, then your c is negative. So for example, in this case is, well, if I give you sine 2x plus 3 pi, your c in this case is negative 3 pi, not 3 pi. Okay, and your b in this case is 2. So in order for you to find the phase shift, the symbol for phase shift is this symbol. We call it phi, a 0 and a slash. The formula is c over b. So in this case is negative 3 pi over 2. So c is negative 3 pi and b in this case is 2. So I just want to point out to you, a lot of students make mistake in my test is because your c in this case, it has to be negative inside here. So if you see a positive, then the c is negative. And if it's negative, then it's positive. What is this phase shift means? Phase shift means that you move your horizontal shift. That means you move it left or right. So when you see this negative 3 over 2, it means that it moved to the left by 3 over 2. So imagine it used to be your sine, let's say let's start sine wave. So your sine wave is used to be from 0 here. So what happened is that all these points will be moved to the left by 3 pi over 2. So this 0 will be at negative 3 pi over 2. This 2 pi will be at pi over 2. I will teach you how to do that. Don't worry about that. So how do you get it? So your graph will look something like this. That means it's been moved left 3 pi over 2. And if this is a minus 3 pi over here, it's a plus, then your phase shift in this case is 3 pi over 2, means you move to the right. So instead of that, then your graph will be something like this, where it will start at 3 pi over 2. So this is the meaning of phase shift, means you move to the graph either left-hand side or to the right-hand side, depends on him. So if you see a plus, means you move to the left. That's why your value is negative. And if you see a minus, then you move to the right. Okay, so this is a little stuff that you guys need to know, very important. And the last thing we have in this is the D, the last one, D. What is D means? D means that you just move it up or down. So you move the graph up or down. So that means that if you have a D, like a 2 means you just move this graph up 2 if a D is 2 units. If it's a D is negative 2, you just move it down. So all the points move down. So this is the transformation that we have. So instead of you doing all this left, right, up, down, and so on, so this is the way that we always do in this class. So we don't do up, down, left, right. So you have to figure out what is the end point and the start point and the end points of the equation. So what do I do here is I take bx minus c equals to 0. That is this value inside here. And then we take bx minus c equals to 2 pi. And the reason why I make it 0 and 2 pi is because both sine and cosine actually starts from 0 and ends on 2 pi. So if you take this value inside this equation and you take bx minus c equals to 0 and you solve for x, okay, you solve for what is x value in this case. This will tell us the starting point of it, and this will tell us the ending point of it. Okay, so that means we can start from. So this will tell us the moving left, right, and also your period, okay, your phase shift and your period. And then what we need to do is, because if you look carefully here, is there are 4 additional points. 1, 2, 3, 4, because they got 4 quadrants. So in order for us to figure out what is the next x values in this case, what we do here is we take the period and divide by 4. The reason why we take the period divided by 4 is because we've got 4 quadrants, and then this x value that you have, you keep on adding to it, so you will end up with 4 different points, and that's where you do your sine width. Okay. But then we also need to worry about your y value, because your y value used to be from -1 to 1. So your y value is going to be will be changed, depends on your A and your D, because A means it's an amplitude, means you go up and down. So you have to multiply by A. So if your amplitude is 3, so this one will go up 3. And don't forget, A can be negative. So if it's a -3, then instead of going up, if your A is negative, then your graph is no longer going up, down. It'll be like going like this. Okay, that means it's been reflected to the x-axis. And also it depends on the D. D means that you move up and down the graph. So so this is very important. So I'm going to put it down here. So this is how we graph your sine and cosine and secant and cosecant graph. Is you will need bx minus c equals to 0 and 2 pi, where it starts and ends, and and then after each x values, you have to take the period divided by 4. And all the y values you have to multiply by your value of A, and then you add or subtract with the D value. And class, don't worry about that. I know this looks like what he's talking about. I will show it to you an example. Okay, so you guys will know what's going on. So let's take a look at an example in this case. Let's do this one. So we want to figure out what is the graph this. So you do not need to describe the sequence of transformation. You just need to graph this. So this is the new way to do it, or your textbook way is showing you this way. So let me show you how to do it. This is very, very important, and this one costs around like 10 points in your test. Okay. Y equals to negative cosine 2 pi x. Okay. So the first thing I always tell my students here is to tell me what is your A, B, C, and D. Okay. So to figure out what is your A, B, C, and D in this case, you will need to look at this and compare. So A is the one that's out front, the sine and cosine. B and C is inside the parentheses, so make sure it's inside the parentheses. And D is at the end when you add or subtract. So the A in this case is a -1 here. That is outside here. Your B in this case is next to your X. So in this case is 2 pi. This is your B. C and D, we don't have any because we don't have an addition. We don't have a parenthesis here. And then we don't have an addition D here. So that is your C and D. But since this question doesn't have that, so we don't have C and D. Okay. So what we need to do after you find your A, B, C, D is to figure out what is your amplitude, your period, and your phase shift. Okay. And don't forget the formula is the amplitude is the absolute value of A. The period is 2 pi over B. And the phase shift is C over B. So this is the formula to finding amplitude, period, and phase shift. So in this case, since our A is -1, so our amplitude in this case is 1. So again, don't forget amplitude is how high and how low your Y value is. Okay. Your period in this case is 2 pi over B. Since our B is 2 pi, so it's 2 pi over 2 pi. So 2 pi over 2 pi in this case is 1. So what does that mean when I say your period is 1 is from one cycle to another cycle. This is cosine, not sine. So it's a whole value here. So that means this starts from 0 and this ends at 1. That's the meaning of the word period here, means where does it start and where does it end. I mean, the whole thing is only, the whole period here is only 1 in this case, you should be 2 pi. And then C for the phase shift is C over B. Now, since we don't have a C because we don't have anything, so there is no phase shift involved. When I say no phase shift involved means that this graph do not move left. It does not move to the right. So don't forget the C that you see here is telling us the graph moving left or right. So we don't have one, you don't move left or right. So so this is how we figure out your amplitude, period, and phase shift. Very important. So the next thing we're going to talk about here is your where do you start and where do you we need to figure out your 5 points here. So we're going to figure out your 5 points in this case. So how do you figure out your 5 original points here is you remember the cosine wave, or if you want, you can look at your unit circle. The first point that we have for the cosine in this case will be 0, 1. Where do we find 0, 1 here? So if you remember your cosine wave, save this first and then I can show it to you. Yeah, this is a bit more challenging. So let me show you the cosine wave. So do you see the first one we have is 0, 1? That means the point here is 0, 1. The second original point in this case is pi over 2 and 0. So this will be pi over 2 and 0. Okay, so that is the second point. The third point is pi -1. The next one we have is 3 pi over 2, 0. And then the last one is 2 pi and 1. 2 pi and 1. And if you doesn't know how to find these 5 numbers, I showed you before on the previous Zoom. Or if you want, you can take your unit circle and do the 0 pi, the x and y axis, and you look at your x values because it's a cosine graph here. So that is your cosine here. So now we need to find what is your final points. So in order for you to find what is your final points in this case is you have to take the starting point of this and the ending point of it. And how do we figure out starting and ending point is to take the bx minus c equals to 0 and bx minus c equals to 2 pi. Okay, so what is bx minus c for this question? The one next to your cosine or the one next to your sine. So your bx minus c in this case is 2 pi x equals to 0. If you look at the next example, your bx minus c for this question is only x. Okay, and if you look at number 7, your bx minus c in this case is 6x plus pi. So if you see parentheses, everything inside the parentheses is your bx minus c, and if you see this, x over 2 minus pi over 4 is your bx minus c. So this is the bx minus c that we talk about. And what you do here is you have to figure out what is the starting point and what is the ending point. So you take that equals to 0 and you take it equals to 2 pi and you solve for x in this case. So you divide this by 2 pi. So x in this case is 0. And you divide this by 2 pi. X in this case is 1. So what is this telling us? It's telling us that this number, these endpoints, the x values, will start at 0 and it ends at 1. So this 0, 1 that you're telling us is the x value. This is all for the x value, where you start the x value at 0 and it ends at 1 in this case. And how do we figure out what is the additional x values that you have? Is you take the period divided by 4. So since our period that you found earlier is 1, so in this case, it will be 1 over 4. Okay, so what you do here is you add 1 over 4, add 1 over 4. So you keep on adding 1 over 4. So 0 plus 1 over 4, you get 1/4. And then you add another 1/4. 1/4 plus 1/4 is 1/2. And then 1/2 plus 1/4 is 3/4. So this is your, and then 3/4 plus a quarter is 1. So how do we figure this x values here is you take your period and then you divide it by 4. And the reason why we divide by 4 is because we got 4 quadrants. So we add a quarter each. Okay, and then that's how you get your x values. Now we need to figure out your y values. So this is the x value that we do. So how do we figure out your y value in this case is you take all the y values that you have on your on your original points, you multiply this with a and you add with d. So what you do in this case is our a in this case is -1. So you take all the y values in this case and you multiply this with -1. And we don't have d, so we don't need to worry about adding d because the question here doesn't have d. So what you do here is you multiply this one with -1. So 0 times 1 times -1 is -1. 0 times -1, you will still get 0. Okay, don't forget we are multiplying this with -1. -1 times -1, you will get a +1. So you get 1 here. 0 times -1 is 0. And then 1 times -1 is -1. So what do we need to, so this endpoints, the y value in this case is depends on your a and your d. Since your a is a -1 and we don't have a d, so we take all this y value and multiply this by -1. So now this is our endpoints for our cosine. And usually in a test, I need 2 full periods or 2 full cycles. So how do we draw it is, let's say we got a fraction. So I'm going to first do dots here. So 1 is 0. So I put this is 0 and 1 is -1, 2, 3, 4. So this is 0, -1. And then we got 1/4. So this is a quarter and this is at 0. 0 is right here. And then we got 1/2. 1/2 is here and 1, 1, 2, 3, 4. This is 1. And then 3/4 will be at 0. So this is 3/4, and then 1 negative 1 is right here. So then what you do is you draw your wave up. And since I need 2 cycles, 2 cycle means you repeat. So you repeat back. So this is -1, 0, 1, 0, -1. So this is -1. So you go back to 0, and then you go back to 1, and then you go back to 0, and then you go back to -1. So this point that I dot is this answer, negative cosine 2 pi x. So let me just draw it out nicely on my pad here so you guys can see. This is tough. I didn't say this is easy. So we will be using these 5 original points. So 0, -1. So the first one is 0. This is 0, and then -1. And then you got 1/4, 0, which is this fellow. And then you got 1/2, 1. And then you got 3/4, 0. And then 1 will be at -1. So this, and then you repeat 0, 1, 0, -1. So this graph that I draw here is your cosine graph. The answer for this. -1 cosine of pi x. This is 2 cycles. 2 cycles means I need two wave or 2 cosine wave. So this is your answer in this case. So if I draw the graph, it'll be up and down. Questions? A lot to process? Difficult? Yep, it is difficult. Questions you guys have?
So I have a question. How come you did not multiply by 1? Because isn't that our A?
Our A is 1 here because that's your amplitude. This is 1.
Oh, okay.
Okay. The reason why you multiply by not the capital A, the amplitude, but the small a is because the small a has a negative. So remember, originally your cosine graph is this way. So once you multiply with negative, your cosine graph will look the other way like that. That's the a, the -1 makes it looks like that. Let me do a few more because this is tough. This section is a little bit difficult. Okay. So let's try number 6 here. Y equals to 2 sine x minus 3. Now don't forget, this one does not have a parenthesis on it. So do not simply put a parenthesis because this and this are 2 different. If I want to put parentheses on question 6, where should I put it?
X minus.
Just x. So if I want to put parentheses, just here. That means that what is your A, what is your B, what is your C, and what is your D in this case? A in this case will be 2. B is the one next to this x, in this case will be 1. We don't have a number next to the x here because it's the parenthesis, so we don't have a C. So C is always next to the x inside the parenthesis. And this -3 you see here is not your C, but is your D. Okay. And don't forget, D means you move the graph up or down. Okay. So amplitude, period, and phase shift. Amplitude is the absolute value of A. So in this case, it's just 2. Okay. Period is 2 pi over B. And since our B is 1, so the period in this case is 2 pi, because this is 1. Phase shift is C over B. Since we don't have C, C is not given to us, so that is no phase shift. Again, no phase shift means we don't need to move it left or right. So now we will do your original points. So this is our original points, and then this is your final points. Now remember last time for cosine, your original point is this 0, 1, pi over 2, 0, pi, negative 1, 3 pi, 0 and 2 pi 1. That is for cosine. So this time is for sine here. So again, how do we figure out the sine original points? You can look at your unit circle if you want to. Let's look at the unit circles, make it quicker that way. Since you're allowed to use this. So now we use the 0, pi over 2, pi, 3 pi over 2, and 2 pi, but we look at the y value because sine is a y value. So the first one, look at 0. What is the y value for the 0 degrees?
0.
It'll be 0. And then a pi over 2, what is the y value for pi over 2?
1.
1. And then pi will be back to 0. And then 3 pi over 2 is negative 1. Okay, so we got 3 pi over 2 with negative 1. And the last one is 2 pi back to 0 in this case. Your y value in this case is 0. So this is how you figure out your sine wave. You look at the y value, cosine, you look at x. Okay. So this is your original points. So now we need to find your final points. So in order for you to find the x value for the final points, you have to take the bx minus c equals to 0. This is where you start. This is where you start. And this is where you end. You take bx minus c equals to 2 pi. This is where it ends. Okay. So what we do in this case is we look at what is inside the parentheses. So whatever inside the parentheses is your bx minus c. So since inside the parentheses, in this case, we only have x. So the good news is, so that means you start from 0 and you end at 2 pi because our bx minus c in this case is 0. This is our bx minus c, what is inside the parentheses. So it's telling us you start from 0, you end at 2 pi. And then in order for us to figure out what we add on to it, we take the period divided by 4. And by looking at our period that we found early on, which is 2 pi divided by 4. So this is pi over 2. So what do we do is we have to add pi over 2 for every single one of this. So 0 plus pi over 2 is pi over 2. Pi over 2 plus another pi over 2, you get pi. Pi plus another pi over 2 is 3 pi over 2. And then plus another pi over 2, you get 2 pi. So this is how you figure out your x value. How do you figure out your y value? You multiply by a and you add d. So by looking at your equation, our a in this case is 2. So we will multiply this by 2. And our d value in this case is minus 3. So what does that mean, class, is these are all your original y value, which is 0, 1, 0, negative 1, and 0. So you have to take all this times 2, subtract 3. Okay, so you have to do secant 1. So what is 0 times 2, subtract 3, minus 3? What do you get?
Negative 3.
You get negative 3. This is 1. So what is 1 times 2 minus 3?
Negative 1.
0, we just did it over here. So 0 times 2 minus 3, this is negative 3. Can someone tell me what is negative 1 times 2 minus 3?
Negative 5.
And the last one is 0, which is we did it, times 2 minus 3, you get a negative. So this is how you determine your y values, is taking your a and your d here. We multiply by this a and we add or subtract by d. Depends on what the value d you get, positive or negative. And then you just apply to all these y, originally y value, the 0, 1, and -1 here by this. So now we can graph this equations. So the first one we have is 0 minus 3. Sorry. Maybe a little bit out because they're all in the negative. So 0 minus 3 is somewhere here. Minus 3. So 0 minus 3 is this. And then pi over 2. So the next one we have is pi over 2 is at -1. And then we got pi is going to be back at -3. And then 3 pi over 2 will be at -5. So this fellow will go a bit down to -5, right below here. And the last one is 2 pi is going to be at -3, which is right here. So this is your answer for this case. And I need 2 cycles. So then you just dot it the same way. So the next one is go up to -1. And then you go back down to -3, -5, and then back to -3. So we got next cycle will look something. And don't forget, your cycle can go to the right, and your cycle also can go to the left. It doesn't matter which way you draw your cycles. And make sure you know there are you need at least 2 cycles for your answer here. And class, make sure also that this is in a graph paper. This is no graph paper. This is like a freehand drawing. So the graph paper looks very similar to your notes here. So make sure you know how to draw your sine wave with this. And read, like how I know this is 1 box per dot. So make sure you go 1 box per dot. If you're using 2 boxes per dot, then your sine and cosine wave is a little bit wider because you use 2 boxes per unit instead of 1 box per unit. Okay, you can do it. Just make sure you know how many boxes. If you use 2 boxes here, then every single one of these will be counted twice. Okay, that means your graph is a bit wider. Okay, but if you use only 1 box, then your graph is a little bit smaller. So it's up to you. So make sure you have enough room to do 2 of the cycles. Anyone have any questions for me? Okay, now I'm going to teach you how to do the sine, the secant and the cosecant graph. Yes, we're going to do the secant and cosecant graph. So again, I'm going to do the basic one first. So this is 6.5 now. Okay. So as you guys know that, what is the reciprocal of sine? Is that secant or cosecant? Anyone? Reciprocal of sine? Secant or cosecant? Which one?
Cosecant.
So so we're gonna do the cosecant in this case. Okay. Yes, don't do secant. I'll be wrong. Now, how do we draw a cosecant theta? In order for you to draw the cosecant theta, you need to draw the sine theta first, which is this red line that I draw. This is a sine. And what you do with this cosecant theta is you have to draw me 2 asymptotes. One is the horizontal asymptote. So your horizontal asymptote is bound by your range, means it's bound by -1 and 1 because that is your range in this case. So that is your horizontal asymptote. Your vertical asymptote is the one that it is when your original point is at 0. So remember your y value is at 0. So it will be at 0, 0. That means it's on that like an x-intercept. Pi 0, 2 pi 0, and then it will be 3 pi 0, the next one, and then 4 pi 0. So what do you notice when I draw this vertical asymptote is you got the whole hump, like one big hump, or you whole hill and a whole valley. So in order for us to draw the cosecant graph, you just do a reflection of it. So I'm going to do this in, let's say, green, so you can see it. Not green. Let's do gray. So you got this that is going up. So your cosecant graph will be the one that I draw in gray. Okay, this I will draw this graph that I draw is your cosecant. This will be your cosecant graph, and I just want to point out to you that it actually touched at 1 and it touched at -1. So at this, it will be at -1. So actually it touched. Okay, so everything here touches at 1 and -1. So this that you see here, the little up and down sign that I draw, is your cosecant graph in this case. So in order for you to draw the cosecant graph, you need to draw the sign, and you have to give me your asymptotes, and then you do the up and down. Now, make sure that the asymptote that you draw here is completely one full hump like this, or one full hill, and one full like a valley. So if your cosecant, and when you draw your asymptotes, and let's say this is your sine wave that you have, and let's say your asymptote that you draw here is partially hump and or hill and partially here down, this is wrong. Okay, I can tell you this is wrong. So that means that when you draw me the secant or cosecant graph, your asymptote, your vertical asymptote has to be exactly one whole hill like this and one whole hump. So you cannot do partial one, part way and a part way. So if you do a partial like this, your asymptote is totally wrong in this case. Okay. Now, what is your domain in this cosecant graph that you have, the gray one that you have? Your domain in this case is all real numbers. X cannot be, or your vertical asymptote, because your vertical asymptote is the one that that it cannot take from, because it has it's like a rational function. So you cannot take that. And if you look at this, it's going to be 0, pi, 2 pi, 3 pi, 4 pi. So we say all real numbers except x cannot be k pi. Okay, because it means 0, 1, 2, 3, 4, 5, 6, 7, 8 pi, and -1, 2, 3, 4 for the other one. Your range in this case, because it is you jump from -1 to 1. So your range in this case is -infinity to -1 included, and then 1 to infinity. So you jump from here and then jump from 1 to infinity. So that is your range for your cosecant graph. It does not have a y-intercept, and it does not have an x-intercept. The reason why is because this graph will not cross on the y, and it will not cross on the x-intercept. So it's the end. This graph is an odd graph, means it is symmetry with the respect with the origin. Okay. So so this is in 6.5. You learn the cosecant graph. So if you want to draw the cosecant graph, you will have to draw the sine graph first, and then you do the up down up down. Okay. Questions with this? Same thing happens to the secant graph. So we know secant graph is based on cosine. So if I want you to draw, oh my God, this one's a lot of blue lines. Let me erase all these blue lines here so you can see it. I don't want your lines here. So if you want to draw your secant graph, so the first thing you need to do when you draw a secant graph is you have to draw the cosine graph first. Okay, so when you draw this, you need to draw the cosine graph first. So so we're going to talk about this one. Y equals to secant theta. So what we do is the same thing as cosecant graph. What you do is you draw me the asymptote first. Again, your horizontal asymptote is bound by your 1 and -1. And don't forget, if you move up, down, your 1 and -1 will also move up or down. That will also move, your horizontal asymptote will be moved up or down. Okay. And then when you look at your vertical asymptote is bound by the zeros. So now the 0 is no longer at 0, pi, 2 pi, 3 pi. It's going to be pi over 2, 3 pi over 2, 5 pi over 2. So this is your vertical asymptote in this case. So if you look carefully on the vertical asymptote, it's going to be all odd over 2, like pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, negative pi over 2, negative 3 pi over 2. And you notice that when you do this, you get the whole, again, the whole like a minimum here, or like a go open downwards. So what happens to your secant graph? Your secant graph will be going this way. This is your secant graph. And then this will go the other way. This will go this way. And this will go up. So anything that goes a hill is go upward. Anything that's valley, it goes downwards. So this is your secant graph. It's very similar to cosecant graph, but you need to draw the cosine graph in this case, and you do the up down. The domain for this secant graph is all real numbers, except x cannot be all this number, pi over 2, 3 pi over 2, 5 pi over 7 pi over 2. This is called as pi over 2 plus k pi. Okay, so that means if k is 0, you get pi over 2. If k is 1, you get 3 pi over 2. K is 2, 5 pi. K is negative 1, you get negative pi. So you include everything. Your range in this case is from negative infinity to negative 1 included, means that this fellow will touch at 1 and negative 1. Okay, they will touch here. And then it goes from 1 to infinity, which is the same range as the cosecant graph that you have. It does have a y-intercept. Your y-intercept in this case will be at 0, 1, which is this fellow is your y-intercept. But it does not have an x-intercept. Okay, it does not have it because it never crossed on it, because it's go up here or down there. This is also an even graph, which is symmetry to the y-axis. Okay. So this is also an even graph, the secant graph. So this is the secant graph in this case. Anyone have any questions on the secant graph here? Try to do 2 sections here. All right. So how do we draw a secant graph? We'll do one. Or cosecant graph. Let's say we do question number 7 here. So instead of doing cosine, I will change this into secant. Everything the same. I will change it to secant. So, but we have to draw the cosine graph first. Okay, we still have to draw the cosine graph, and then after that, we draw the secant graph. Again, how do you draw your cosine graph? You need to know your ABCD. So by looking at here, can someone tell me what is my A, my B,
-3.
-3, B?
6x.
No x. So like slope, you don't give me x, just 6 is enough. Okay. C, do we have a C in this case? Yes. Don't forget, C is inside the parenthesis. So what is C in this case? Pi or negative pi?
Negative.
Okay, so be careful. For C, your sign has to be changed. So if you see in this parenthesis has a plus, then it's negative. If you see it's a negative, then it's a plus. Do we have a D in this case? No, we don't have a D because we don't add anything. Okay. Amplitude in this case is the absolute value of A. So in this case, it will be just 3. That's our amplitude. Take the absolute value of -3. Period in this case is 2 pi over B. And since my B in this case is 6, so this is 2 pi over 6. Can someone reduce 2 over 6?
1 over 3.
So it's pi over 3. Yep, pi over 3. So what happened is that your period of the cosine wave used to be from 0 to 2 pi. Now it's going to be from 0 to pi over 3. So it shrank. Okay, it shrank in this case. Now we do have a phase shift in this case. Your phase shift is C over B. C in this case is negative pi, B is 6. So it's negative pi over 6, C over B. So this means that your graph is moving to the left by pi over 6. The negative means you go to the left. Okay. So what do we need to do next is to give me that 5 original point for cosine. You guys remember the original points for the cosine?
0, 1, pi over 2, 0, pi over pi negative 1, and 3 pi over 2, 0.
So yes, that's correct. So is this one, or if you do not know this, you just refer back to your unit circle. You just use your x value in this case. Okay, so 0, 1, pi over 2 will be at 0. Pi will be at negative 1, because if you look at this, your x value is negative 1 at pi. And then 3 pi over 2 will be at 0. And then 2 pi will be at 1 here. Sorry, my bad handwriting. This is 3 pi over 2. Okay. And what we do next is we need to figure out your y value, your x value in this case. So how do we figure out your x value? Is you have the starting point and you have the ending point. So you take whatever inside your parentheses here, 6x plus pi, you make it equals to 0 because you start at 0. And then you take 6x plus pi, you make it equals to 2 pi because that is where it ends. So for sine and cosine, same thing with secant and cosecant. Your cycle starts at 0 and it ends at 2 pi. So when you solve for x, does someone help me to solve for x here? Move your pi over, so you got 6x equals to negative pi. So divide by 6, x is what? Negative pi over 6. So that means you start at negative pi over 6. And then you subtract pi here. So in this case, 6x is pi. 2 pi take away pi is pi. And then divide by 6. So x in this case is pi over 6. So that means it ends at pi over 6. So it starts at negative pi over 6. It ends at pi over 6. And the next thing we need to figure out is what do we need to add on to this? You take the period divided by 4. And our period in this case is pi over 3. So does anyone know how to take pi over 3 divided by 4? This is a lot of students doesn't know how to do this in my test. So anyone know what's pi over 3 divided by 4?
Is it 4 pi over 3?
Nope, good try. And that's where I also get wrong. So you don't put the 4 on top. This is the same thing as what? Pi over 3 divided by 4, right? Okay, you guys know what to do with this division symbol? Change the division to become what?
You can make it times 1 over 4.
Yep. So in this case, this is the same thing as multiplied by 1 over 4. So this is actually what? Pi over 12. Or if you want, if you take 3 and 4 and multiply, you get 12. So pi over 12 in this case. Okay, so that's the fastest way. So if I ask you what is pi over 8 divided by let's say 4. Anyone know what is pi over 8 divided by 4 is?
Pi over 32.
Yep, pi over 32. This is the fastest way to do it. So you just take 8 times 4. But what happens when you have pi over 8 divided by 1/4? Then this 4 goes to the top as what Gamal said early on, remember? So this will become 4 pi over 8, which is half pi over 2. Okay, so make sure that if this is a fraction with a fraction list, you just multiply 32. But if you see another fraction, this 4 goes on top, because when you multiply 1/4, you flip it, become 4. So that's why the 4 goes to the top. Okay, so what we do here is we have to add pi 12 to this. So we have negative pi over 6 plus pi 12, because this is our first thing, is we're going to add pi 12 here. So we can multiply this by 2 to make it 12. So this is actually negative pi 12. So when you add pi 12 to this, you get negative pi 12. And what happens when you have a negative pi 12 and you add another pi 12? You will get 0. 0 plus pi 12, you will get pi 12. And pi 12 plus pi 12, you get pi 6. Okay, so this is how you figure out your x value. It's hard, it's not easy. Okay. Now for the y value, what we do? We multiply by a and add d. So you have to take all this y value that you see here, and you have multiply. What is a in this case? You have to multiply this by what? Negative 3. And the good thing is we don't have a d. So we do not need to add or subtract d. So what you need to do is take all this y value and times 3. So it's 1 times negative 3. So you get negative 3. 0 times negative 3, you still get 0. Negative 1 times negative 3, what you get?
3.
3. 0 times that, you still get 0. 1 times negative 3, you still get negative. So this is your graph.
Cosine graph.
That's your cosine graph. You're correct. It's not your final graph yet. That's your cosine graph. I'm going to draw it
I
down.
have a question.
Mm-hmm.
When we find the opposite, when we find the secant for this graph, how would we find the points for it?
Oh, sure. You don't. You just find the cosine graph of it, and then after you just make it up and down.
Oh, so you're
Okay.
not going to ask for the points for the.
These points are for cosine. If I ask for secant, you have to draw the cosine graph for it. You draw the cosine graph, and then you just reflect it. So we have now. This is something I want to point out to you. This one that you find here, the period over 4, this is actually your unit for your x unit. What does it mean by x unit? Means this is your x unit. That means that how you determine what is your x unit is determined by this p over 4. So this means that every single one of this unit is pi over 12. Okay, this is how you figure out what unit to use. Is this p over 4, and this is negative pi over 12. This is negative 2 pi over 12. Negative 2 pi over 12 is the same thing as negative pi over 6. So this is negative pi over 6. We have to go down to negative 3. So negative 3 is here. So this is your first point for your cosine graph. Negative pi over 12, 0 is this fellow. And then 0, 3 is this. Pi over 12, 0 is here. And then pi over 6, negative 3. So pi over 6 is the one on the next one. It's going to be at negative 3. And then if I want 2 cycles, you just go back to 0 for the next one. And then you go back to 3. And then you come back down to 0, and then you come back down to negative 3. So this graph that I draw in a dashed line here, the one that looks like a cosine graph that will be reflected on the y-axis. That is the -3 cosine 6x plus pi. Okay. But now we need to find the secant of it. So for us to find the secant, then you need to have a horizontal asymptote, which is at from 3 and -3. It has a vertical asymptote. Your vertical asymptote is where it cuts on the x-axis. So in this case, will be pi over 12, -pi over 12. Oops, here. What is this one? Pi 12, pi 6. So 112, 212. This is 312. So this is 3 pi over 12. Because don't forget, every unit is pi 12. So 112, 212. This is 3 pi over 12, which in this case will be pi 4 if you reduce it. And then 3, 4, this will be 5 pi over 12. So they're all having 1, 2, 3, 4, 5, 6, 7, 8 over 12. 5 pi over 12. And what do you notice here is, again, this whole thing is a whole a hill. So your secant graph in this case will be open upward. And again, it cannot cross on your asymptotes. This will be going downhill. But it still touch the 3 and -3. And this will go. And we need one more, because if you want two cycles needs 2 ups and 2 downs. So you just draw another one of this, and you just tell me it's cool. So the blue graph that I draw is the -3 secant 6x plus pi. So this is the blue graph that I draw. Questions with this? Difficult. This is difficult. I didn't say this is easy. This is tough. And this worth like 10 points in your test. So make sure you guys, I will do some examples here so you guys can, play around with it. And again, we haven't done tangent and cotangent graph. We just did the secant, we didn't do the tangent and cotangent. Yeah, we only did the cosine, secant, and sine. So we're going to do a cosecant graph. So when you come back on Wednesday, we do the tangent and cotangent graph and the rest of it. Okay. So we're going to do one more, which is the last question here. So before I continue with the last question, I want you guys attendance. Give me your attendance. So number 8. Again, we don't want to do the sine wave, because usually your test, I will ask for secant or cosecant. So sine is the cosecant. So I just changed that to cosecant. So that means you have to draw the sine wave first. So can someone tell me what is your A, B, C, D for this question 8? A, B, C, D.
A is 2/3.
B. Again, it's next to X.
-pi over.
That is not your B. Anyone B?
1.
That's not your B. So if I give you y equals to 3x over 4 plus 2, what is your slope here? Anyone know what's the slope here?
3/4.
3/4, right?
That's 1.
So what is your B in this case?
1/2.
It's 1/2. Yep. Okay, so it's 1/2 here. So don't forget, you all have a 1/2 in this case for your B. How about C?
-pi over 4.
Don't forget to switch it around. Okay. So for C is inside the parentheses and your sign will be switched around. So it's not negative pi over 4, should be what?
Positive pi over.
Positive pi over 4. So make sure you guys know this. It means that if you say negative, means you move to the left. This one actually it moved to the right. Okay. And do we have a D in this case?
No.
No. Okay, there's no nothing here. What is your amplitude in this case?
2 over 3.
So absolute of A, so it's 2/3. Now your period is 2 pi over B, and B in this case is 1/2. So can someone tell me what is 2 pi over 1/2?
So just 2 pi over 1.
Pi.
So
Right.
what you got? Sorry, what is 2 pi over 1/2 is?
Pi.
No, this is the same thing as 2 pi divided by what? 1/2, right? Which is the same as what?
4 pi.
4 pi. Yes, this is actually 4 pi. So be careful with this. So the best way that I'm thinking for you guys, if you are still weak on this kind of fractions, just change this to become a divide, and then you see it more clearly. You know what I'm saying? And then you multiply by 2. So that's why it's 4 pi. Phase shift. What is phase shift in this case? C over B, right? So C in this case is pi over 4. And B in this case is 1/2. So this is a good practice. Everyone, please figure out what is this. Anyone?
Pi over 2.
Okay, that is correct. This is pi over 2. This is the same thing as pi over 4 times 2, right? So that's the reason why you get 2 pi over 4. And if you reduce it, it's pi over 2. Yep. Okay. That is correct. So this is your, that means you're moving to the right pi over 2 in this case. Okay. So make sure you guys know how to do all these basic fraction works, because a lot of students struggle with this. And the best way for I show it to you, I told you, is to make this division as the fraction become a division symbol, then you can see it more clearly. Okay. Then the original point for sine is 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. These are the original 5 points for sine. Again, if you doesn't know this, make sure you use your unit circle. Look at your y value, because we're talking about the sine. Okay. Then for all your x values, we have to do your starting and your ending points. So what is your bx minus c in this case? The one inside your parentheses. So you have to take x over 2 minus pi over 4, and you have to make that equals to 0. That is where you start. And then you have to make this equals to 2 pi, where it ends. So this is the starting and ending point for your x value for your final points. So we begin to solve for this. So you move that negative pi over 2 over there. So become positive pi over 4. Sorry, you move this over, right? So you get pi over 4. 0 plus pi over 4 is pi over 4. And then you multiply this by 2. So in this case, you will start at pi over 2. So your starting value in this case will be at pi over 2. Okay. We same thing, we move it over here, become plus pi over 4. Anyone know what is 2 pi plus pi over 4? Anyone know what this is?
Nine over 4 pi.
So this will become 8 pi over 4, right? Because 2 pi is 8 pi, so this is actually 9 pi over 4. Yep, that is correct. And then we're gonna multiply 2 to here so that this is gone. So this is 9 pi over 2. So this will be ends at 9 pi over 2. And then what do we need to add on to it is to take the period divided by 4. And the period we found early on is 4 pi. So 4 pi over 4, you get pi. So pi over 2 plus pi, so you would add pi in this case, is 3 pi over 2. And then you add another pi, it will be 5 pi over 2. And you add another pi, it will be 7 pi over 2. And then you add another pi, it will be 9 pi over 2. So this is your unit. We'll talk about that later on. This is tricky, a little bit tricky. Next, we're gonna do your y value. So in order for you to do the y value, you had to take all this y value that you see here, and you multiply this with a and add with d. Now we have a in this case is what?
2 over 3.
So we just need to multiply this by 2/3. And we do not have d here. We don't have d here, so we don't need to add or subtract. So 0 times 2 over 3, you still get 0. 1 times 2 over 3, you get 2 over 3. This is still 0. This is negative 2 over 3. And this will end up with 0. So these are your points that you need to draw. But this is for the sine wave. Okay. Now, this is very special. The reason why is because this is pi. So I'm going to do 2 of this is pi. The reason why I'm doing 2 is because this is pi half. So I got another 2. This is 2 pi. Another 2, 3 pi. Another 2, 4 pi. So the first one we have is pi half 0. Pi half 0 is right over here. This is pi half and 0. The next one is 3 pi over 2. 3 pi over 2 is this one. This is 3 pi over 2, between pi and 2 pi. And this is at 2/3. So let's say this is 2/3. So this is your next one over here. And then 5 pi or half. 5 pi half is this below and it's 0. And then 7 pi half is at negative 2/3. So it's right over here. And then the next one we have is 9 pi half. So this graph that I draw in blue is your sine wave. Okay. And if you want, you can draw it another round like this. Again, you got graph paper, it'll be easier for you to draw. So, but we are drawing what we call as the cosecant graph. So cosecant graph needs you to draw the asymptotes. So the horizontal asymptotes is 2/3 and negative 2/3. Okay. The vertical asymptote is where it counts the 0. So it's gonna be pi over 2, 3, this one, 5 pi over 2, right over here, sorry. It's a little bit wider than the other one. And then 9 pi over 2, and then this 2 over here. How do you figure this 2 out? You can add 2 pi's to it. So because from here to here is 2 pi. So if you add 2 pi or subtract 2 pi, because we do it that way, this will become negative 3 pi over 2. And this will be negative 5 pi over 2. if you want to do it. So what you see is this is all a whole hill. So your cosecant graph will be the one that goes all the way valley here. And this is a valley, so it will be going upwards. And this is a going upwards. And this is going to be a hill. So the gray graph that I draw is the y equals to 2/3 cosecant x over 2 minus pi over 4. And the blue one that I draw is the sine, 2/3 sine x over 2 minus pi over 4. So make sure you guys, once you got your sine wave, the cosecant wave is quite easy to figure out. You just need to figure out your asymptotes and then you go up and down, up and down. That's how we do your cosecant graph. Anyone have any questions here? So we did the sine, cosine, secant, cosecant graph. So on Wednesday, we will do tangent and cotangent. So I want you guys to go ahead and start working on your online homework. There are 2 online homework due this Wednesday, which will be your 6.4 and 6.5 homework. And also don't forget the student math test is this Friday. So I will kind of like I'll do an announcement again on Wednesday. So you guys take it. That will be extra credit added to your test 3, which is the upcoming test. So if you have any questions for this class, do stay back. If you do not have any questions, you may leave the classroom. So anyone have any questions for me?